Hey guys, so I think it was last week. I kind of record these videos at once, so I don't know when I assign them and whatnot. But you learn how to simplify radicals. So we are gonna do 3 of those and review it today. And then we're gonna take it one step farther, which I promise you is not hard at all and you will be fine. So first problem, the square root of 117. So again, I have no idea what goes into 117. Well, I kind of have an idea, but I'm not positive. So if you have no idea, start with your first prime number. Is 117 divisible by 2? No, it is not because we get a decimal. So move to your next prime number. Is 117 divisible by 3? Yes, it is. We have 3 and 39. So we use 3 and 39. Look at your list. Are either of these prime? 3 is, so circle it. Now we have 39. We don't circle 39 because it's not on our list. So you should know at this point 39 is an odd number, so it's not going to be divisible by 2. Let's see if it's divisible by 3. It is. We get 3 and 13. So we know 3 times 13 is 39. So 3 and 13 go here. 3 is prime, so we circle it. 13 is prime, so we circle it. If you notice, all of our numbers at the bottom of the branches are circled, so we can make our nice radical. List them from small to big. And you know that we also circle pairs because we're working with square roots. Pairs have to be the same number. So circle a pair. When you cross off a circle, you know one of those numbers comes to the outside. So 3 is on the outside of the radical. 13 is left underneath. So your answer is 3 root 13. Next one, we have 63. You might be good at your multiplication tables and you might say, hey, I know that 7 times 7 times 9 is 63. And you can go from there. If you didn't, you would start with your 2 and then go to 3. So you say to yourself, are either of these numbers prime? 7 is prime, so circle it. Is 9 prime? No, it's not, which means you need 2 more branches. What times what is 9? Hopefully you know it's 3 times 3. 3 is prime, so you circle both of them. If you look at your branches, they all have circles on the bottom. So draw your radical. List from small to big. Circle your pairs, which have to be the same number. When you circle a pair, cross it off. One number from the pair comes out. And really simple, I have 3 on the outside, 7 on the inside. So 3 radical 7. Or 3 times the square root of 7. All right, next up, square root of 100. Some of you might have known this was a perfect square and you don't have to do the work. For those of you who don't, you say to yourself, what times what is 100? Hopefully you would say 10 times 10, or you could use 25 times 4, or you could use 2 times 50, or 20 times 5. There's a bunch of different options. Is 10 a prime number? No, it's not. So you cannot write your radical because you don't have circles. So break it down. 10 goes to 2 and 5, which are both prime, so you circle them. This 10 also goes to 2 and 5, which are both prime. Can you see it if I write it here? Yes. I'm going to list my numbers from small to big. Circle my pairs. I have a pair of 2s and a pair of 5s. When you cross off a circle, one comes out. Cross off a circle, 1 comes out, and don't forget these two numbers are being multiplied. 5 times 2 is 10, and that's on the outside of the radical. Is anything left under the radical? No, it is not. So you are going to take this radical symbol away, and 10 is your answer. Now at the beginning of this, if you knew the square root of 10, the square root of 100 was 10, you did not have to do all of this work. But if you didn't realize that and you got down to here and you got confused, that's what happens. All right, new stuff, but I promise you it's really not that bad. So sometimes you're gonna have a number on the outside of your radical. Have no fear, it's really not that bad. What you're gonna do is you're gonna draw your radical. You are going to bring your number here, and then you're gonna cross it off and forget about it for the time being. So 2 numbers that multiply to 48, if you had no idea, start with your first prime number. Is 48 divisible by 2? Yes. What are my 2 numbers? 2 and 24. Are either of those prime? 2 is, so circle it. What times what is 24? You have a ton of options. I'm going to pick 4 and 6. Now, are either of these 2 numbers prime? No, they're not. You cannot write your numbers under the radical yet because your bottom legs do not have circles. What multiplies to 4? 2 and 2, which are prime. You cannot write these numbers under the radical yet because you have an uncircled number at the end. What goes to 6? 2 and 3. And now you finally have all circles, so you can list from least to greatest. I'm going to erase my arrow just to make my life easier. So now circle your pairs. We have a pair of 2s and another pair of 2s. Notice how I didn't circle a 2 and a 3. The pairs have to be the same. Cross off a circle. One of the numbers comes out. Cross off the other circle. One of those numbers come out. This is the biggest mistake people make. 2 times 2 times 2 is not 6. If you click the answer that says 6, you are wrong. 2 times 2 is 4, times 2 is 8. So 8 is on the outside, and what's left underneath? 3. Not too shabby, right? Right, next problem, 10 root 64. Again, you have a number being multiplied outside the radical, but you're not going to freak out. You're just going to take this number and drop them down here, then cross them off and ignore them. 64, what times what is 64? Hopefully you said 8 times 8. Or if you use this method, you would have gotten 2 and 32. I think you could have used 4 and 16 also. I think that's it. Are 8s prime? No, they're not. So they both get arrows. What times what is 8? 2 times 4. We know 2 is prime. 4 is not, but 4 breaks down to 2 and 2. Same thing over here. 2 times 4 is 8. 2 is prime. 4 breaks down to 2 and 2. Now we have all circles at the end, so we could write them from small to big. I'm going to get rid of my arrow. Circle my pairs. Ooh, did I miss a number? I did. There's 6 2s and I only wrote 5. So when you cross off a circle, one number comes out. Can you even see this? Yeah, you can. Cross off a circle, one number comes out. Cross off a circle, one number comes out. 2 times 2 is 4, times 2 is 8, times 10 is 80. What number is left under the radical? Oh wait, there are none. Ew. So 80 is just your answer. Now, if you had been up here and you realized that 64 was a perfect square, you could have skipped all of this work and said to yourself, oh, this is the same thing as 10 times 8, which is 80. So if you know your perfect squares, your life is going to be a lot easier. All right, 2 more, and then you are good for today. So again, I have a number on the outside. Set up your radical and bring your 12 down. Cross him off. Break down your 12. Use whatever numbers you want. I'm going to say 2 and 6. We know 2 is prime. We cannot write these under the radical because this one is not circled. It is not prime, so we know it breaks down more. These are both prime. If you look, all of our bottom branches are circles, so list from least to greatest. Circle your pairs. I'm going to erase my arrow. Cross off a pair. One of the numbers comes out. 2 times 12 is 24. What's left under the radical? 3. All right, and last but not least, 5 square root 195. Again, we have a number outside the radical, but we're not going to be scared of it. We're going to write it here. Cross it off and forget about it. If you have no idea what goes into 195, start with 2. Is 195 divisible by 2? No, it's not. We get a decimal, so move to 3. Is 195 divisible by 3? Yes, it is. 3 and 65. Are either of those prime? 3 is. Looking at this number, I don't know what multiplies to 65, but since it ends in a 5, I know it's divisible by 5, so I'm just going to see what 65 divided by 5 is. It is 13. So I'm going to have a 5 and a 13. Are either of those prime? They both are. So if you notice, all my bottom branches are circles. Do I have any actual pairs to circle? No, I don't. So that means that I can't simplify this. I can't simplify this radical. So what happens is you leave the 5 on the outside and you just multiply those back together. So 3 times 5 times 13 is 195. So your answer is just your starting radical. Bye, guys.